Hello everyone, today we're going to go over the blind 75 in C++, and today we are working with remove nth node from end of list. Now, before we get started, feel free to pause the video. For whenever we are breaking down our following question, we always need to ask ourselves these 4 questions. What are inputs going to be? What data structure / algorithm / technique to use? What to do with the data? And finally, what are outputs going to be? So, to be able to give a rundown over exactly what this problem entails, just breaking down the problem. Given the head of a linked list, remove the nth node from the end of the list and return its head. Okay, so it looks like all it's asking us to do, just from the problem, is that we are given the head of a linked list and it looks like here, okay, and wants us to remove the nth node from the end of the linked list. Okay, so from the end of the linked list. So we have the second node accordingly, and we remove that, and therefore we have 1, 2, 3, and 5. Same thing for, well, if we have 1 in particular, and we remove the first index, since we are removing from the end of the list, that's kind of tricky to start. We're then going to have 1 accordingly. So that's why in particular we have this input and the output. So from the end of the linked list, the output is a new linked list with the output, or hang on, with the nth node removed. So there we go, between our relationship. And so the technique to introduce you folks to that's going to help us solve our problem is going to be 2 pointers. We have 2 elements of data we will put at the head of the linked list, as well as a second pointer after the first pointer. And this will help us scan throughout the rest of our linked list, given the fact that we were just given the head, so we can remove our nth node. Okay, and the following steps in order to break down the following problem are as followed. So for step 1, we're going to initialize our 2 pointers at the head of the list. Then we will move the first pointer n nodes ahead from the end, and we will use a for loop to iterate through. And then if the first pointer is null, we return the next node of the head, and this means n is equal to the length of the list, and we need to remove the head node. And then we need to move both pointers until the first pointer reaches the end of our linked list from the n, and then we will make the next of the second pointer when n is removed to the next of the second pointer, which will remove the nth node from the end. So we scan it once, ultimately, then we scan it a second time to be able to remove our following linked list accordingly. Since we are given the head, our first pointer ultimately really starts from the beginning, scans through, and then our second pointer is going to scan backwards, since we already have our pointer, our first one already scanned accordingly, so we can then figure out exactly where to remove from the nth node. And then we'll just return our head once it's fully updated. So the way how to break down this following problem in the number of steps is that step 1, we'll have a list node represented first, which will be the head of our given linked list, since we're starting from the head. And then we'll have node and then we will have our second equal to the head just to initialize, and then we're going to iterate through throughout step 2 for int I is going to be 0, I is less than n, and I plus plus. Then first is going to be equal to the first next node while we are scanning through. And then step 3, if first is equal to null, we will have to return the head as an edge case for next. Then for step 4, while first is next and it doesn't equal null, in this case, we will set the first node to be the next of the first node after, so it will be after head, and then second will be second to next. Finally, step 5, we are going after the first node, scan through, then we are going to update our list with second, next, and next. Finally, returning the head of the new list. All right, putting it up here. Okay, let's just run this to double check. All right, passes all the test cases accordingly and submit. Okay, and just give a rundown and breakdown of our time and space complexity for the following. The time complexity is O of L, where L is representing the number of nodes in the list. And this is because we simply traverse the list in just one pass, while the space complexity, on the other hand, is O of 1, because we only use a constant amount of space to store our 2 pointers. And yeah, so this was remove nth node from end of list. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.